Welcome to Science Access. Today we'll be talking about temperature part 2. Please, if you know you are new to this channel, kindly like and subscribe so you get notification when we post a new video. Today we'll be doing interconversion of temperature scale. Please, if you know, please to get a better understanding of this temperature part 2, please go back to our previous video. Now, the first interconversion we are going to do today is from Kelvin and Celsius scale. Now, we are going to use interpolation rule. Now, this rule, this is the lower fixed point for Kelvin. This is the what we are looking for. This is Kelvin. Why this is the upper fixed point for Kelvin. Now, using interpolation rule, we have Kelvin minus the lower fixed point, which is 273, which is what we have here, divided by the upper fixed point, which is 373, minus the lower fixed point, which is 272, which we have here. So we do it for Celsius scale too. We have degrees Celsius minus the lower fixed point, which is here, divided by 100, which is the upper fixed point, minus 0 degrees Celsius, which is the lower fixed point, which we have here. So what do we do next now? We subtract. So K minus 273, which we have here, 373 minus 273, which is the upper fixed point minus the lower fixed point, which is 0, equal to degrees Celsius minus 0 is degrees Celsius, divided by 100 minus 0, which is 100. Now, the next step, we have to multiply both sides by 100. Multiplying both sides by 100, we take 100 to the other side, while we take 100 to the right hand side. So, multiplying both sides by 100, we have 100 in brackets, Kelvin minus 273, which is the lower fixed point, divided by 100, equal to 100 multiplied by degrees Celsius, divided by 100. Now, what do? We divide. So, here, what are we going to divide? We use 100 to cancel 100. And we use 100 to cancel 100. So we are left with Kelvin minus 273, which is equal to degrees Celsius. Now, we have gotten the formula for Kelvin and degrees Celsius. Here now, to get the formula for Celsius, we have degrees Celsius equal to Kelvin minus 273, which is the same thing as what we have here. Degrees Celsius equal to Kelvin minus 273. Now, if you want to, we can also get the formula for Kelvin from here too, which is Kelvin equal to 273. When this minus comes to this side, it becomes plus, then plus degrees Celsius, which we have here. So this is how to derive the formula for the interconversion of Kelvin scale and temperature scale. Now, let's look at some examples under Kelvin and temperature scale. So, Kelvin and Celsius scale, So, number one example here. On a winter day, the thermometer record a temperature value of 30 degrees Celsius. Tell the temperature in Kelvin. Now, in this question, they ask us the temperature in Kelvin. So, we have to go back to the formula we derived from here. The formula for Kelvin is 273 plus degrees Celsius. That's the formula we're going to use to find Kelvin here. So, what is our degrees Celsius? From the question, our degrees Celsius is 30. So, Kelvin equal to 273 plus 30. 273 plus 30, that is 303. So, Kelvin equal to 303. Now, we can also convert this Kelvin to Celsius using the same formula. Celsius equal to Kelvin minus 273. Now, to find the Celsius back, we have Kelvin. What is our Kelvin here? 303. 303, then minus the 273. Now 303 minus 273, then we have 30. So you can see that our degree Celsius is 30, which we have in the question. Now we move to number 2. Number 2, if a rod have a temperature of 85 degrees Celsius, what will be the temperature on a Kelvin scale? We still use the same formula. The formula for Kelvin, 273 plus degrees Celsius. So what is our degree Celsius in the question? Our degree Celsius is 85. So we say 273 plus 85. So our final answer for this question is 358. We can also convert from this Kelvin back to degree Celsius as we did in our number 1. So to convert from Kelvin back to Celsius, the formula we are going to use is still the same thing as degree Celsius equal to Kelvin minus 273. So what is our Kelvin? Our Kelvin is 358 minus 273. So 358 minus 273, we have 85. So our final answer for converting Kelvin to Celsius is 85. Now we move to number 3 question. Number 3 question says, what will be the temperature of water in degrees Celsius if the temperature is 423? Now we also use the same formula for degrees Celsius, which is Kelvin minus 273. Now what is our Kelvin in the question? Our Kelvin is 423. So using the formula, we use 423 minus 273, which we have here. So 423 minus 273 equal to 150. So our answer in degrees Celsius is 150. Now converting this degree Celsius back to Kelvin, we also use the same formula for Kelvin, which is Kelvin equal to 273 plus degree Celsius. Now we have our degree Celsius here, which is 150. So we take our degree Celsius as 273 plus 150. So adding 273 plus 150, we have 423 Kelvin. So our Kelvin equal to 423. Now our number 4 question says, if a solid metal is at temperature of 302 Kelvin, what will be the temperature in degrees Celsius? We also use the same formula, which is degree Celsius equal Kelvin minus 273, where our Kelvin is 302 from the question. So degree Celsius equal 302 minus 273. So 302 minus 273, our degree Celsius is 29. Now taking this degree Celsius back to Kelvin, we use the same formula. Kelvin equals 273 plus degree Celsius. Now what is our degree Celsius? Our degree Celsius is 29. Kelvin equals to 273 plus 29. Now 273 plus 29, we have 302. So our final answer for this question for converting degree Celsius to Kelvin is 302. Now we move to the second interconversion of scales. So now we'll be doing Fahrenheit and Kelvin scale. So we use the same formula we use for the first one, which is the interpolation rule. We have the higher fixed point here. Then this is Fahrenheit, what we are looking for, and this is the lower fixed point for Fahrenheit, which is 32. And on the Kelvin scale, we have 273 as the lower fixed point. We have our Kelvin here, and we have 373 as our higher fixed point. Now, using interpolation rule, Fahrenheit minus the lower fixed point, which we have here, divided by higher fixed point minus the lower fixed point, which is 212 minus 32, which we have here. So we move to the Kelvin scale. So we have Kelvin minus the lower fixed point, which is 273, which we have here, over higher fixed point, which is 373 minus 273, which we have here. Now, what next? We subtract 5 minus 32. We have it here. 212 minus 32 is equal to 180, equal to Kelvin minus 273 over 373 minus 273, we have 100. So what do we do next? Now we cross multiply. So cross multiply, we have 100 here, which is 100 in bracket 5 minus 32, which we have here, equal to, we bring 180 here, so we have 180 in bracket Kelvin minus 273. Now, after this, we divide both sides by 130. Now we are looking for Kelvin. We are looking for Kelvin, so we divide both sides by 180 using this equation. So we have 100 in bracket 5 minus 30 equal to 180 in brackets Kelvin minus 273. So we divide by 180. So dividing both sides, we use 20 to divide both sides. 20 here, we have 5. 20 here, we have 9. So 180 cancel 180. So we say 5 over 9, which is here, in brackets 5 minus 323 minus 32 equal to Kelvin minus 273. So our final answer for deriving the formula of Kelvin is Kelvin equal to 5 over 9, which is this, in bracket 5 minus 32. Then this minus will come to this place, minus 273 will come to the opposite side, which is plus 273. Now this is the formula we derive from converting from Fahrenheit to Kelvin. Now we can also use this equation to convert from Kelvin to Fahrenheit using the same equation. So from the equation we have 100 Fahrenheit minus 32 equals to 180 in bracket Kelvin minus 273. So we divide both sides by 100 because we are converting from Kelvin to Fahrenheit. Now we remember 100, we got 100 when we subtract the higher fixed point from the lower fixed point, we got 100 for Kelvin. So we use the 100 to divide both sides here from the equation. Now dividing both sides, 100 cancel 100. Now 180 and 100, we use 20 to divide. When you use 20 to divide here, we have 9. When we use 20 to divide here, we have 5. So we have Fahrenheit minus 32 equal to 9 over 5, which we have here, in bracket Kelvin minus 273, which we have here. So our final answer is Fahrenheit equal to 9 over 5 in bracket Kelvin minus 273. Then taking minus 32 to the opposite side, we have plus 32. So this is how to derive the formula for Fahrenheit when converting from Kelvin to Fahrenheit. So let's take some examples on this. So number one example here, we have on a hot summer day, the thermometer records a temperature value of 373 Kelvin. Tell the temperature in Fahrenheit. So from here, our formula from here, we have Fahrenheit equal to 9 over 5 in brackets Kelvin minus 273 plus 32. So this is the formula we derived from our interconversion that we are going to use. So what's our Kelvin? Our Kelvin is 373. So Fahrenheit equals to 9 over 5. Then our K 373 minus 273, then plus our 32. Fahrenheit equal to 9 over 5. 373 minus 273, we have 100. Then plus our 32. Fahrenheit equal to, we use 5 here to divide. 5 here 1, 5 here 20. So that's how we got our 20 here. Then plus 32. So Fahrenheit equal to 9 times 20, we have 180, plus this our 32. So 180 plus 32. So our final answer for Fahrenheit is 212. Now we can also still convert from this Fahrenheit to back to our Kelvin using our formula we derive from the time conversion. So what is the formula for from Fahrenheit to Kelvin? We have Kelvin 5/9 Fahrenheit minus 32, then plus 273. So to convert back from Fahrenheit to Kelvin, we use this formula. Now Kelvin equal to 5/9. What is our Fahrenheit? Our Fahrenheit is 212. In bracket, 212 minus 32 plus 273. Now what do we do next? We first deal with the one in bracket. So our Kelvin equal to 5/9. Subtract 212. Subtract 32 from 212. We have 180. So in bracket, 180 plus 273. So what's next? We divide 9 in the 180. So we have Kelvin equal to 5. Here 1, here 20. So in bracket here it will be 20 plus 273. So we multiply. Kelvin equal to 20 times 5, 100 plus 273. Kelvin equal to 100 plus 273. We have 373 as our Kelvin. So that is how to convert from Fahrenheit to Kelvin. So we move to our second example, which says if the temperature of a body is 194 Fahrenheit, what will be the temperature value in Kelvin? Now, so we are converting from Fahrenheit to Kelvin this time. So using our formula, Kelvin equal to 5/9 in bracket Fahrenheit minus 32, which is the lower fixed point, plus 273. What's our Fahrenheit here? Our Fahrenheit is 194 in our question. So we replace 194 here. Then minus 32 plus 273. So our Kelvin equals to 5/9. 194 minus 32, we have 162 plus 273. So our Kelvin equal to, we divide 9 from 162, we have 18. So 5 in bracket 18 plus 273. So Kelvin equal to 5 times 18, we have 90. Then plus 273, which is here. Then 90 plus 273, we have 363. Now, converting back from Kelvin to Fahrenheit using the formula, Fahrenheit equal to 9/5 K minus 273 plus 32. Now, converting back to Fahrenheit, we use this same formula. So, what is our Kelvin? Our Kelvin is 363. So we equate equal to 9/5, 363 minus 273 plus 32. So what do we do here? We deal with the bracket first. So we have Fahrenheit equal to 9/5, 363 minus 273. So we have 90. Then plus 32. So what do we do here? we divide. Fahrenheit equal to 5 in 90. We have so 5 in 90 we have 18. So we have 9 in brackets 18 plus 32. So we multiply 18 times 9. So we have 162. So our Fahrenheit equal to 162 plus 32. So 162 plus 32. We have 194. Our Fahrenheit equal to 194. So that is our Fahrenheit for converting from Kelvin back to Fahrenheit.